Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Mojan Sohi. Welcome.
Hey, Mojan. Good talking to you again.
Hi, Fred.
When we were off air there, we were chatting a little bit about this, that, and the other thing, and I've come to expect already that it's, do you got any ideas for topics? And you had a list of 4 things, and all 4 we're going to have to get to. And I think we'll probably add more to it as we talk. I think there were 2 or 3 that weren't on this list from that Rapid Fires episode a week or so ago, that a couple weeks ago now when this airs, that we need to revisit. I think AI was one of them. We'll have to come back to. I actually got a call yesterday from a CEO of a small AI startup, and he was explaining how their system worked and where it used AI and stuff. It's pretty cool, but
nice.
It doesn't solve world hunger or anything like that. But it was, kind of nice.
But that's the bar. Is that the bar we have for?
Oh yeah, or for any technology, pretty much.
Of course.
Yeah,
yes,
of course.
It's good. We have a high bar.
You have to have goals.
You have to have goals.
Right. And I think later today, you and I are going to be talking with a client about goals and apportionment, basically a basic block diagram.
Yeah.
But you also mentioned this in the context as an idea, is that how does setting goals, and I think there's more to it than just setting goals. Anybody can set a goal and just ignore it, so it's not a problem. And the speed, the desire to get to market quickly. And I'd like to unpack that a bit, because the goal itself is the goal. And it's like, the product has to be less than 5 pounds and this color blue and stuff like that. It's just an expectation of what we'd like it to be, right? Whereas if you actually can't launch until you meet the goal, well, that's a problem, even if you have 5 years, not just 6 months. So I'm like, what was your thinking in this topic?
Yeah, I mean, I think a related concept within this that probably listeners can relate to, and what probably often comes to mind, which I think is something that you and I have talked about before, and we educate folks on lots, is that they tend to associate reliability with testing, and the common conception is that in order to achieve reliability, you have to do lots of testing, and the testing takes time. And how do you fit that? Today's product development timelines are getting shorter and shorter, and in order, how do you fit the meeting your reliability goal within those timelines, such that they you can show that you've met your requirement if you have a reliability requirement.
Yeah.
So I think that's a common thought, and what people probably think of when we think about, like, product development timeline and reliability in conjunction.
Okay. Well, I don't.
Yes, I know. I know. I think this is why it's a good topic, because
Right.
I think we can talk about how you can shift the mindset from thinking that way around reliability to what would be more useful, and to kind of break this. I think this is maybe it's a strong word, but I think we can call it a myth, and I think we can kind of break the habit, to talk about it. So yeah.
Why it's not a dilemma for me is that let's use the example. If you have no goal, you have 6 months to design a product, and you do no testing, just the extreme. The opposite of what most people think of when they think they have to do certain reliability. Let's say they don't even think about it at all. It's just the product is going to have some reliability performance over time. It will either be great, or it'll be miserable, or it'll be okay. Right? It will be what it is. It's part of physics and math and just science, and it's just materials. it's a accumulation of all the decisions that went into making that product. Why did they choose that metal? Why did they choose that fastener? Why did they choose this, that, or the other thing, right? Independent of whether you thought about reliability at all, it
Mm-hmm.
will have a time to failure distribution. It will do what it's going to do, right? The reliability is, and I think the word mindset is the right thing, is that how do we actually achieve that color blue that they wanted the on the data sheet, on the engineering requirements? Well, we look at our color options and how we're going to apply the color, and we might talk to somebody that does the different pigments and how, if we're going to paint it, for example, and we say we want this hex value blue. And you don't have to test it. It's not required to achieve that blue, right? It's a good check, a verification step. Did we actually achieve the color we want? And it only takes a few minutes to check it. But the idea is that they made all these decisions prior to that testing. And it's the
Mm-hmm.
same with reliability. If you design a product and you have a prototype and you say, oh, we got to do reliability now, well, you already did. And I think that's the
Exactly.
point.
Yeah.
You already thought this through. You already did consider the impact on reliability or not. And so it's that mindset of it's part of your very early concept and material selection and vendor selection and assembly processes. It's part of those decisions. It testing is how we check it. And it's only one of many methods of how we check it. So reliability does not equal testing at all. It's just apples and oranges in my mind.
That's what we should make the title. Reliability does not equal testing. I think that's a good title.
There we
I
go. All right. We'll just
agree.
make a
Yeah.
note.
Yeah. Yeah.
And we'll test whether all the podcast systems can handle a non-alpha character. It's the not equal
Yeah. I'm
sign.
curious.
Yeah, it might.
Exactly.
It's a
Yeah.
standard ASCII character that should handle it. Or it'll be some gobbledygook thing in the middle and make it very interesting. We should test it.
We should test it. Hey. Hey.
But
Yes.
but the idea is, I think the fundamental concept, the different way to, I, I think the proper way to think about reliability and your product or your system or your production line is that it is what it is, whether or not you test it. Now, if you really, really need to know, and it's a $1 million decision, do we launch or not launch? And if it doesn't meet this XYZ value of reliability performance on day one, then we lose everything. Well, then yeah, you go test it and take the time to go do it if it's that important. But
Mhm.
if it's more important that you get into the market and more important that you get in front of customers and get that process started, you have the option to completely ignore reliability. And I should put in parentheses here, at your own peril.
Mhm.
But a better
Mhm.
way is, set a goal and use all the ways, all the tools that we have available to estimate what the system's reliability is going to be. And it may involve testing on some elements of the system, and it may not. It may use educated guesses. It may use vendor data. It may use, just the existence of our prototypes and how well do they perform. And then, oh, this one failed due to this. All right, let's do a simulation study of this or a finite element study. Why did they get that much force? How often will they get that force? And you can sort out a reliability figure or merit for that. And there are a lot of ways to get there without waiting 6 months to run a test.
Yes, definitely. In fact, I was talking to someone yesterday who was mentioning they're like, so is there, yeah, I had experience in reliability testing or in reliability in my working with the teams in my past jobs, and we did all these tests that took 3 months. I think one of them he mentioned took 6 months, and
Mhm.
I just couldn't help but think it's like, well, by the time you get that information,
You're already shipping.
you're already shipping. Like, what are you going to do with that information? And so, I was like, I think the better way to do it is to think about what are we trying to do? What's the purpose of the test? But
Yeah.
with related to this, I think one common question that has come up, I've seen come up in the past with especially with leaders in product development organizations who maybe not are not as familiar with design for reliability is okay, so how do I measure DFR as I'm going through the product development cycles, like because mass you can quantify in a way through, your uh, mass simulations and estimations,
Hmm.
for example. Durability, you can run simulations. Even in automotive, of course, like NV has simulations. Like you can quantify aerodynamic performance, like all these different metrics that are or attributes that are typically uh, have targets, they have goals, they have KPIs that are used in product development, depending, of course, on the industry,
Hmm.
are quantified. And so they are like, okay, so how do I quantify reliability without test, until I get to testing? Let's say I do need to do the testing. How do I quantify my DFR until then?
Yeah. One of the most interesting examples I got was involved with was the company was making a syringe type system, and it delivered some drug for some overdose recovery kind of thing. And the FDA said, well, it has these moving parts. How reliable are they? Will they always work? Will it get the full injection? Will it do this, that, and the other thing? And so they broke down all of the mechanisms, the spring strength, for example. Let's just use that as an example. And they went out and measured 30 springs, got a rough, shape of their inherent strength. And then they measured, well, what's the other forces on this? And there was a plunger thing that had some friction, and if that dimension varied, then it would exert more pressure or less pressure. So they did an estimate of what that range would be based on their tolerancing of their molded parts and this uh, gasket that was in it, and stuff like that. And they just did a stress strength calculation. They said it has to be in this range to work. When it's outside that range, it doesn't work as well. And if it's way outside the range, it doesn't work at all. And the product was well designed, and it was most likely just going to work. But there was a very small probability that the dimensions would cause it to just be too much resistance for the spring to overcome, and it would underdose. And
Mm.
but it was like a fraction of a part per million. And when you lay out the logic of that, you look at it and go, well, that makes sense. And they looked at the next part, the next critical piece in their system, and they use simulations of, well, what's the range of values this can be, and what's its distribution. And in some cases, they could go measure stuff. Some cases, they needed to know what would be the pressure of a person's hand. Well, there's books already published with how strong people's hands are to push a button or twist something or do whatever. You can use that data to do a Monte Carlo simulation saying, here's how reliable it is. We know what it needs to
Mm.
be to work, and we can get the environmental stresses or the internal stresses or the variability of what's going on, and we can simulate it with very few, if any, measurements. And you get a figure of merit or a reliability aspect for that element or that feature or whatever aspect of it is. So it was, and they methodically went through their system because the, it had to be so reliable that the basic simple calculation of sample sizes was in the tens of thousands.
Mm.
And
Because the target was so high.
yeah, because if it's one latch, for example, on a system,
Hmm. Hmm.
and for the overall system's goals, it needed to be in the part per trillion type figures. And there's no way you're going to go test that. You just can't possibly get enough samples. And I think one of the pieces of it was more than their expected production at full volume for 10 years. So
Mm.
it's like, no, we're not going to go do this. And what I run into way too often is somebody who say, well, they have that mindset, well, we have to do testing. And so I can't get 10,000 samples. Well, I can get 10, so I'm going to test 10. All right. Well, think this through. If you test 10 for that feature that you're trying to determine, is it in a part per trillion failure rate realm or not, you're going to get no information whatsoever from 10 samples, other than then if one of them fails, then you know you've got a really bad design or something's really wrong. But if you test 10, it does not prove that you are good to where you need it to be. So stop wasting your time thinking you're doing reliability testing, on air quotes here, with not enough samples. Instead, look for another way. And it might be Monte Carlo, it might be simulations, it might be stress strength type approach, it might be physics of failure type approach, it may be, understand how it really fails and go, oh, it needs oxygen to do this. All right, well, that's an Arrhenius equation. Chemists already know how that works. Let's go look up how fast does this corrode and lose mass. Okay, now we have an answer. There are lots of ways to do it other than just go, oh, I got to test it.
I'm going to play devil's advocate here for a second and tell you what I usually hear when I suggest these is that okay, but I don't know what the parameters of my Arrhenius model or whatever other model are, and I don't want to just use estimates from the literature, or I don't know, whatever, or maybe the literature, the values don't even exist in the literature. And
yeah, the Arrhenius one is the one that's most common people want to go to, and they don't want to, and they shouldn't just use a rough estimate because the activation energy value is critical. But using that example of, let's say it oxidizes. Well, that's a chemical process. It actually is a chemical process, and the Arrhenius equation really does apply. Go talk to a chemist. Say, all right, here's this process. What's the activation energy for this set of materials in this process? And I've done that in the past, and it takes them a day or two to run a quick experiment to determine the activation energy for that equation. And nowadays, I'm quite sure they can just simulate it. Once you know the chemical equation, you can calculate the activation energy. You don't need to run unknown or blind if you understand the failure mechanism. And if you don't know the failure mechanism, why did you pick an Arrhenius? Like, you don't understand the problem well enough
then how did you
to just
determine
make
that
that
it would be
assumption.
Arrhenius anyway? Yeah,
Yeah,
exactly.
that's what I say.
Yeah, that's interesting. I haven't done that before. So yeah, you can. I guess that makes sense. You can run it, the reaction and figure out
What it takes to actually work. And I'd lean on a chemist for that because it's a bit outside. Chemistry is just a fancy physics, but I always piss them off when I tell them that. Yeah. I'm a physics major in undergrad, so everything's physics, everything. And chemists don't like hearing that. And my daughter's studying chemistry, and I said, what kind of chemistry? She said, the stinky kind. We're like, okay, I really don't want to know about that. Organic chemistry, I think, of some sort. But yeah, there's a whole lot of knowledge out there. We can tap into that. And, if it's, sometimes we really are blind, right? We don't really know how the customer is going to use it. Well, we make all kinds of mechanical engineering decisions, assuming it's a triangle distribution or a square function in an electrical engineering circuit or something like that. We can do that for reliability too, saying at worst case, it's a uniform distribution in a square from this point to this point. And we can set the points however we want, make it very aggressive or very conservative or whatever, and we can get a number. Now, it might not be the best number in the world, but you get it pretty quick. And then you can say, well, if it's in this realm where we're being very conservative and we are overestimating its expected failure rate and it's good enough, we'll stop. Don't worry about it anymore. Move on to the next part that you need an estimate for.
Yeah, I think that makes sense. I think I'm very curious. I would love to put this and maybe our conversation later today would be a good case, but I would love to put this into practice and see, because part of me thinks, and I feel this is what maybe people would say as well, is that, oh, but this is, my system is extremely complex, how can I really run a Monte Carlo simulation for this? Or, the reaction is super complex. Am I really going to be able to talk to a chemist and figure out what the reaction is, figure out the activation energy for it, et cetera. Because in today's world, like most of the products that we work on are, you know, they have some proprietary components to them, thinking about chemistry, and then they also are just generally complex systems. So to your point, I think you can simplify it, but yeah.
Yeah, at the heart of it, it's usually pretty simple. I mean, a latch is a latch. It has a spring force and it has holding force. Period. It doesn't matter what that latch looks like, right? What materials or anything else about it. Yet we can probably simulate that pretty quickly in a finite element system. So it's there. Part of it is just step back and be a little bit creative. If testing is going to take you too long, well, that's not an option. So think, do something else. Don't just throw your hands up going, well, we can ignore reliability now. No, not if you really want to create a product that works and as expected. No, you got to pay attention to it. And complex systems, yeah, it may take some more thinking, and more guessing. But if it's that complex, you're doing that already with the design process. You're not fully paying attention to fully characterize every aspect of the design already. Focus on the critical ones and use that as your basis for reliability too. So I don't know, it sounds like a conspiracy theory. Oh, we just have to do testing.
I mean, I'm sure you've heard lots of people say this as well, right? Like I hear it a lot. It's like,
no, I hear it all the time, and it's like, no, wait a second. Yeah, let's think about it. And that's now I have a podcast episode to say, hey, go listen to that.
Yes. Yeah, I think this is a great starting point for lots of people who think that, testing reliability equals testing. And we're going to title this reliability does not equal testing.
Does not equal testing.
Yes.
It's not even correlated to it. I mean, you can do really bad tests and you still have great reliability. So it's like that. Anyway, now if you're listening to this and going, oh, you didn't think about this, or you should have asked this, or this is another objection I get all the time. Well, that would be great. We'd come back and talk about this again. Or there might be a couple other ideas of how to, evaluate or measure the metric of reliability in your system that we didn't touch on. That would be also very helpful for future audience and all of our education. So let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Mojan and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways to get your thoughts over to us and be part of the show. We'd love to have you.
Yeah, absolutely.
It's one of the things that Chris Jackson says is you really can't check your brain at the door when you go to work, and more so with reliability. We got to be creative and thorough, and that involves thinking. Sorry about that if you're not thinking now, but you're listening to the show, so I know you're good. You're thinking, so that's all good.
Yes. I think people are good at that. I think it's just like an education thing. I think it's common misconceptions, and that's why we're talking about it.
Yep, exactly. All right, thanks so much, Mojan. We'll talk to you again soon.
Thank you.
Okay. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.